Hi, I'd like to welcome you to another in a series of webinars designed in this particular case for transportation agencies. This webinar is going to be a little bit unique. I think it's going to appeal to state departments of transportation, to metropolitan planning organizations, and to state and county and local government. So we have a unique and webinar today, really focused on the transportation networks of the future. I'm Terry Bills. I'm the Transportation Industry Manager here at Esri, and today I'm joined by Michael Helander, the CEO of Airspace Link. As I mentioned, this is a topic really looking at, if you will, the transportation networks of the future, and really focused on how really drones and UAVs are going to become more ubiquitous in our urban and environments, and how we really need to start planning for that today. So let me just, we are recording this webinar and to let you all know, and we will have a question and answer period at the end of the webinar, so you can type your questions into the question box, and we'll try to answer as many as time allows at the end of the webinar. Additionally, the webinar, for those, if you have colleagues that weren't able to attend today but would like to, or you'd like to have them see this, will go up on our website roughly in about 3 or 4 days. As well as the slides that you see in today's presentation will be made available to you on our GeoNet site as well. So with that, let me really start kind of laying a little bit of the background to it. So the FAA has actually reported that there are currently 6 companies that are well along in pursuing, quote, certificates for urban air mobility. That is, the vehicles that will fly human passengers. And 4 of those have indicated that those will be autonomous. So those are the air taxis of the future. And it's not so far off in the future. Additionally, we have any number of retailers, everyone from Amazon to any number of other retailers that have indicated that really they will be using UAVs for small package deliveries. So we are going to be facing an increasingly, if you will, congested skies with smaller drones, smaller UAVs, and I think it's time that we really need to start thinking about how we do create these networks of the future. And so that's why I think the timing, having Michael from Airspace Link to discuss their offering and really how governmental agencies can begin to address these issues. So I would encourage you to take a look. Michael was involved, and Airspace Link was involved actually with a project in the greater Detroit area. Any number of jurisdictions and areas are beginning to look at how can they capitalize on the technology, in essence, to make themselves more attractive from a location development perspective. So I'd encourage you to take a look at this case study that we did just last fall. And again, I really think that this is a really critically important topic for the aviation department of state DOTs, for MPOs to think about how they think about these future networks, and certainly for states and counties and cities. So with that, let me actually turn it over to Michael and to take it away with today's presentation. So Michael, over to you.
Excellent. Thanks, Terry. Let me make sure I'm getting the right monitor here.
You are?
Excellent. Thanks, everyone, for joining. I'm really looking forward to this because there's a lot of things happening in the industry. Anything that you see today it's all either running live or it's the data that's supporting it. We cater Airspace Link to two groups. One is transportation departments, some economic development, but we do have a product that you'll see that you have access to. It's on the ArcGIS marketplace, which is called AirHub for Government, and think of that as a transportation planning tool for UAS and that integration. And then we have AirHub for Pilots, which is being used by hundreds of pilots today to fly through the US. So you can either get for local governments, which will be great here. If you have a local government or transportation or university domain in your email, go to AirHub for Government, and I think maybe we'll post some of those links. That's important because that is where almost think about it as building the roads. So to describe what Airspace Link does, we're similar to Google Maps in the ways for drones, but the roads don't exist yet. Where they have the benefit of the roads and the infrastructure already being in place, that the rules, the regulations, the speed limits, the guardrails, all of that has already been put in place at the federal level, state level, and down to the local governments. And we're doing something similar. So the products that we focus on today are building those roads with the FAA, but now with state and local governments and transportation departments to build out those corridors so that the drone industry can leverage that. And it's being used today from recreational pilots to Part 107, and now we're actually using our system to do site selection for setting up operations that will be kicking off at a decent scale this summer. And these will be operations that are full-time. So with that, let's get into the demonstration. I want to start with, last slide first. What's it look like? And I'm going to pull up a video here. I don't know how well it's going to come through, but this is what it looks like when the systems are in place based on different types of operations. So I'm going to mute this. So when the corridors and all the regulatory systems are in place and the communications and the networks, everything required for supporting drone operations, this is an example of two different flights happening. One is, accessing and ordering something through your normal ordering process, whether it be through Amazon. But then what happens is a route is created, and it figures out what is the optimized route through the community, and then there's an authorization process that happens. From there, they have a launch site, so site selection, where does this site allow for drone takeoff and landing? And what it's doing here is that drone is taking those waypoints, not just based on federal rules and regulations, but what's it flying over? In this case, a lot of the rules are the number of people you can fly over. So this systems like ours are helping build those corridors based on all the different rules and regulations to ultimately deliver a package or do a pipeline inspection or agriculture spraying, whatever it might be. It's the ability to build a safety case and have the infrastructure and digital infrastructure to support these types of operations. And that's a sweet spot where GIS really comes in, is that digital infrastructure and building those roads and then maintaining them. So this is an example of what it looks like where it's being tested and starting to build those roads. So when we talk to communities and states and transportation agencies, there's a massive opportunity here, and we're actually working with different groups to, what's the value of the air, and where we have planes, they're plenty high, there's plenty of airspace. When you get to 400 feet and below, it's worth a lot, and there's and we're going through the process of figuring out what areas are worth more than others. But this is a new type of mobility. Just like scooters showed up on your doorsteps, drones are very close, and I'll explain why and when. The nice thing about the FAA is they do not want that to happen. That just drones just start showing up like they did with scooters, and it's a bit unregulated, and it was definitely an issue where the FAA is easing drones into our communities through a process. But it has a lot of benefits from saving lives. Public safety is using this a ton right now. We're actually supporting drone organ deliveries in Ohio in a couple weeks. We've had COVID test kit deliveries through Syracuse, New York, through downtown, from hospital to hospital, helipad to helipad. So starting to use drones for good and those package deliveries. New job opportunities, revenue. A lot of the studies that we're working through right now have been published are, the amount of people that could be accessed by drones into certain communities. The time savings, the number of people that can get access to things with mobility challenges, avoiding the number of car crashes, CO2 emissions. So this goes into a lot of transportation planning process, and there's a way to quantify that through the data that's supported from state and local governments. On that challenges side, public acceptance and community engagement is really important in these early days. So, companies, we're working with drone delivery companies to do drones for good, package delivery, not really in the public safety area, on the surveillance side, but that'd be very valuable. But at the same time, we're trying to do Meals on Wheels deliveries just to introduce it into communities so that it's easier to integrate. Building the infrastructure, how is it built? Who's maintaining it? And there's some gray area about who actually owns the airspace. And it's not just gray area, it's the FAA. But the FAA needs support in supporting drone operations that are so close to the ground and supporting the infrastructure and maintaining it to support safe flights within our communities. Enforcing rules and regulations, policies, and all of this are going through a process right now. So where we're at today, Airspace Link, we've been in the mix for a few years now, and this is the steps that the federal government has taken through the rules and regulations to safely integrate drones, whether it be building out Part 107 and the licensing, where I'm a drone pilot and I have a commercial license to fly drones here in the US. And then they built out LANC, which is the Low Altitude Authorization and Notification Capability in 2017, which we became a part of. And we signed a public-private partnership with the FAA to support the integration of drones into the national airspace. And we do that today through our applications. The next piece that was just approved early this year was final ruling for remote ID and flights over people and flights at night. Think of that as, okay, we put in the rules, the regulations, the roads, and the authorization process to authorize a flight, almost like a toll road. But how do we enforce that? How do we know who's actually flying and where they're flying? And that's where remote ID is now the next rule, that is all drone manufacturers have 16 months to build in this broadcast of your telemetry of where your drone is flying and who you are. So when it's bought from the store, it will actually integrate into our system. There's also been an integration with the IPP program, which the FAA focused for the past 3 years on how to integrate into state and local governments, and that just completed. So where we're at today, so everyone understands, is that process has all been closed. The Part 107, recreational pilots, all of that is complete and up and running in our system. You'll see it live today. The next piece that we're working on over the next 2 years is we're on the Beyond program, which is flying beyond visual line of sight. Over the next 2 years, we're working with Reno, North Dakota, and a few test locations throughout the U.S. To finalize, okay, how do we get drones to fly beyond visual line of sight? So that is underway today. Another big piece and is critical this summer is the FAA Type Certification. So today there are 12 companies that are going through Type Certification that are getting their drones certified. You could say like a Type 135, which is getting a drone certified to do package delivery. Well, this is really important because once they're approved, we'll have an airworthiness. How heavy is the drone? How often does it crash? Which goes into a model that figures out where you can and can't fly, which then applies to your flight corridors through your communities. And that's where the GIS data becomes very important. So as these type certifications happen this summer, these drones will be certified to fly beyond visual line of sight. The next piece is the infrastructure to support it, and the communities and the transportation networks to support that. So these are very critical, and I know Terry was talking about air taxis and and so on. So here's the interesting part. We work with the FAA through Lance and other programs and beyond. Now they're done with the Part 107 pilots. They now have to focus on beyond and flying smaller drones beyond visual line of sight. When they complete that, and that is the FAA UAS Integration Office, they're only one department, so they're only focusing on one thing at a time, at least today. They can't get to air taxi until they finish this next step. So this is, to us, our prediction, this is the year of the drone, or we really can't get to air taxi quick enough, and we have to complete this process before we can really get to the larger drones being integrated at scale. To give you a sense of the drones that we have today, there's roughly about 8.5 million drones here in the US, 250 million worldwide, and that's going to substantially grow. One of the key things I didn't mention on the type certification, imagine this, that these drone companies, they're going to manufacture drones, but they can't go and manufacture thousands of them until they get their type certification, because there might be a change over the next 3-4 months on their wing configuration or the parachute system. So what will happen when that type certification happens, there'll be a massive production, which creates opportunities as well of drones for certain types of operations throughout the US. And there's going to be different types of drones for different types of operations, whether it be medical delivery or rural package delivery or urban delivery. It's really going to be different types of certifications for that capability. So where does GIS and Esri and all of this fit together? So we break it up into 3 parts. The first part is Airspace Link actually spent a full year with the FAA building out that integration Lance to support the integration of Part 107 and recreation drones into the system. We're currently tied into 726 airports, which means drone pilots have direct access to air traffic control to submit flight authorizations. We're the regulatory platform. Our system figures out all the rules and regulations for you, and then we authorize your flight with the air traffic control and create a communications between your airport that you're closest to, and it does it automatically, and we'll see what that looks like today. The second piece, and what's unique to Airspace Link, is our background as a company has come from building out asset management systems, transportation management systems, sign management, traffic sign management, all of that. And so we created a product called Air Hub on the Esri platform, which allows transportation planners to pull existing data to build out these corridors that will help drone pilots stay within compliance. So think of it as we pull in your schools, your hospitals, your jails, your land use, your zoning, street center lines, traffic counts, speed limits, number of lanes. All of that data actually goes into supporting what's called a safety case. And it tells, based on the type certification, where the safest areas to fly through a community, and it builds it out for planners. But then it actually we enrich that data with real-time cell phone data to understand population movements throughout the day. So the flight patterns change a bit throughout the day and how often flights are happening. But this is a tool for the transportation departments to sit across the table from a drone logistics company, and you're going to see how it works, where you can say, hey, what are the best locations to set up operations within your state or your county or your community? And all of that is managed through this back-end tool. So this has nothing to do with drone pilots. This is your transportation planners use this for understanding how to fly through your state. Once we combine the federal system with the local government or DOT, or in most cases, NPOs are now starting to get involved, and probably one of the better spots it sits is that builds out this road network, and we equate everything to cars because it's easier for people to understand, because you can see roads, but you don't necessarily see what's happening in the air. So that does build out that system. And then that data, and FAA data, is combined where drone operators are using the system directly or integrating the APIs into their logistics systems. And we have several logistics platforms that are using this system throughout the US, and they're actually using it not just for operations anywhere in the US, they're using it for site selection within communities. So it's for operating, but it's also for understanding where they can and can't fly and actually doing test flights. So when you combine all of these systems together, whether you're a federal government or you're a transportation department or you're an operator, it's all communicating together, and that's what's showing the data flowing up and down. Communities or transportation groups can now see where flights are happening and how often and when. This will actually turn into a remote ID system in the future, as that's fully goes through its 16-month process. And then operators use this data to build safety cases that then in turn help with beyond visual line of sight waivers. So all, we call it a three-legged stool. These three parts help build out safer flights, more advanced operations throughout the U.S. So to give you a sense, that was the product. But here are the users of the platform. One is the FAA is our biggest integrator. We have a real-time data exchange with the FAA to manage temporary flight restrictions, TFRs, airspace changes, and that is with the for the entire U.S. So that integration is done and complete. Now we're extending it with the Beyond program. Then we have states, for example, North Dakota has gone and said, all right, this is great. As these drones get certified, we will build out the infrastructure and the digital infrastructure to support beyond visual line of sight and drones operations at scale. And they've made a significant investment. We're in a 2-year deployment. We're about halfway through, and that will allow you to bring your drone certification, connect to the operating center, and then submit for flights on their infrastructure. One of the key things about misunderstandings is that, yes, the FAA owns the airspace, but they've put it on the operator to put in the infrastructure to manage their own flights. Well, that's not scalable if every company that wants to fly complex flights has to put in their own infrastructure. North Dakota said, hey, we will pull it in the infrastructure and get the blessing from the FAA for these approved drones to run on this approved infrastructure throughout the state. And that is what it seems to be the scaling factor here, that there is a actual office that was built in North Dakota for integrating drones with manned aircraft and unmanned aircraft into a single system throughout the entire state. And we're seeing that happen, across the states, one after another. But the drivers have actually been coming from cities. So we have some significant logos on here, are companies that are using AirHub for Government that are enabling these operations. And we'll talk about Ontario and Detroit, Seattle, Las Vegas. They're doing some really exciting things that are putting the system and the infrastructure in place to allow these operations that we're going to take a look at. And then we have the operators, where this is becoming a significant flywheel. So think of it this way, in Detroit, they put in the infrastructure and announced to the residents and businesses that we have this new type of digital UAS infrastructure. And then large automotive companies said, this is amazing. We're going to start to do package delivery of parts along our supply chain. Well, then that brought in, well, they don't have their own drones. So that started to bring in drone delivery companies that are now integrating with MDOT, Detroit, automotive company, and logistics companies are actually deploying here. And they're going through a feasibility analysis of certain areas of Michigan to deploy first. And it all really started with the AirHub platform. And now companies like Thales, which we've partnered with, they put in the radar system. So the GIS system identifies areas of missing radar surveillance systems, and then makes recommendations for those hardware companies to put in any gaps in the airspace for low altitude surveillance. So a lot of exciting things. Each one of these logos is doing something pretty amazing. And even Esri has integrated a lot of the drone maps and the data into their own drone software that we'll see as well. So let's take a look at what this looks like. Let me go. And I'm going to break this up into two parts. Building and managing the digital infrastructure, and then using the infrastructures. And that's what you're seeing on the ArcGIS marketplace. You have AirHub for Government, AirHub for Pilots. If you're just a pilot, you can go in here. It's free. the whole idea is that we need people to use it to fly safely. So there's no fee for it. AirHub for government is, well, I don't even know who's flying within our community, how to build it, what are the rules and regulations, and then how do I publish and communicate with the drone industry, with the federal system. So we provided easy integration. It's easier for IT departments because it's just really an ArcGIS Online plugin to your already existing GIS or Esri platform that then consumes data that you already manage to build up a derived set of data that allows you to start to understand how you can fly through your community, but also how to do advanced operations. So all the tools are in place and there. And if you have a government address, this will create an instance of your geography. So if you're the city of Atlanta, when they log in the city of Atlanta, it spins up a server that's only for them, and it's in a sandbox that won't affect the actual airspace unless you turn it on. But we work through that process, but at least you get to understand what's going on. So you have that ability today. It's, again, no fee, just allows you to get in to understand what's happening within your community today. And we are recording all flights that we can within our system. So you understand when and where drone flights are happening. Once that system is set up, this is what it looks like. So whether the city of Miami or Miami-Dade County, first thing that they do is they plug in all of the, we give them a connection to our LANC, our data exchange with the FAA, and that is where can I and can't I fly as of right now. So this is live data. So this gives an understanding of community that I had no idea that, recreational pilots or Part 107 pilots can't fly up to, in this case, 0 feet. So these numbers are that you're seeing here are how high can you fly. So 100 feet, 200 feet, 300 feet, 400 feet. So you're getting an idea of just an understanding of, well, I'm not a pilot, I'm not a drone pilot, but at least I know that it is more difficult to fly in certain areas of the community or county or the state than others. Then we run a risk profile, and that is where drone operators need to understand, well, what am I flying over based on the rules and regulations, and also based on my type certification of my drone. So by changing those variables, you can start to see higher risk areas, and we'll run a live scenario of this. We also go the other way, though. In this case, I'm going to hit how many flights are happening within the area that I'm in. So I just ran a quick report, and I can see that the 119 pilots have flown 200, or actually planned 277 pilots. 277 flights, and then 106 of those were approved by the FAA. So maybe they didn't need to get approved, but so on. But there's a report as you turn this on of what's happening in your community. And then there's you can use different types of insights, Esri products to pull this data in. This is just a simple one for understanding how and when flights are happening, but also mapping it. Again, we're obfuscating where the flights are happening exactly. As remote ID gets fully approved, it goes through the multi-stage approval process where it's approved. It's just waiting to turn it on. We'll be able to see exact flight location, class, and where they're happening live. So that's the neat part, is this is already up and running, and as those new policies and standards come out, they'll just turn on within your state. You can start to see what's happening and how often and where within the system. On the I'm pulling up another city. So the neat thing about this is federal supersedes state, state supersedes county and city, but it all rolls up together. So if I move to this suburb of Detroit, this city has access, and whatever they do rolls up and down, just like roads or parcels. It all fits together. But you can see that this city has actually put in, they have an integration with their 911 system, and I can see that there's an incident that's happening in progress that then has actually been published to the drone industry. So me as a drone pilot, I would get a text message if I was planning a flight in this area. Where I get that today from the FAA with TFRs, but now I'm actually getting local advisories, which is really important to the FAA when they ask you, you're going to fly beyond visual line of sight, but what are you flying over, and how do you know what's happening on the ground? This is how you answer that. For the community or the state, we actually have an advisory insights where we actually run a report. When you start to put an ordinance in place, well, how many businesses and people are you affecting? In this case, you may be potentially affecting 1,000 people and 52 businesses by putting in that advisory. So being able to run reports, and as you change your corridors through the community, there is an impact, and you need to understand that impact. So advisories can be put in, edited, set on schedules, and there's different rules, ways to manage advisories and information about things that are going on within your community. This was actually just used a couple weeks ago in the city of Ontario. There's a major explosion. They put this thing in place, a bunch of really neat things the system was used for that they actually were not allowed to talk about yet, but they used drones to help support, and the system was in place to allow that to happen. All right, so we're still we're still in the planning process. This is for you planners. The next level of the system is we take that data and we are working with the drone logistics companies to do the site selection within these cities. So this is City of Chicago. Now this is where we have the system working in production across the entire country. This is where we're going deep. So we're working and saying, all right, where are the major corridors that for noise pollution, where your train tracks, rivers, whatever that might be, and we start figuring out where you can and can't fly within the community and where's the best location. In this case, how to get from hospital to hospital. So this is the severity levels. These are what we start to call highways in the sky. And there's certain reasons for it. There's about 20 different data sets that are used for at least setting up your first level of review of a community or a state. That data is then processed, and in this case, this is pretty neat. This is the operations are starting to happen, and where is the safest flight based on the type of drone through the community. And you can see the flight paths that are being estimated through the community. So that transportation data that was set up is now being used to figure out how the safest way to get through that. Now you're seeing the raw data here. It's smoothed out and waypoints are all created through this process, but that's what it's looking out from a point-to-point deployments within this location. So that data is being used for pretty deep site selection. This is being done not some with the cities, some with the counties, and some are just, we're working with the logistics companies at 200 cities, and we're figuring out best locations. And if transportation departments and communities are working with them, it sure will make it a lot easier. And that's the whole idea of Air Health and Government is, you know, for this to all work together in one location. I don't know if it's relevant on here. So this is, you can start to change your different types of drones, and you can start to change your different types of operations. And what this does is it's real time. This actually takes into account real-time cell phone data, weather data, all of those factors, and actually makes a real-time map of areas are green, are good, and then, you know, certain red areas, we violated some rule based on the number of people we're going to fly over, or the type of traffic intersection. A lot of those rules are built in, or our flight angles, and what's going on with the local airport as well. So if I started to do a flight over here, and this is for planning purposes. So yeah, we're definitely getting into a rough area over here. All right, all that hard work of building out these corridors, this is where me as a pilot, this is what I see. So up until now, this entire presentation is about building the roads and maintaining them. This is how do I use it. So I'm a pilot, and I'm gonna fly in Miami, Florida. And I'm gonna set up an operation, an advanced one. So I'm gonna put on some of our advanced data, and I'm gonna put up all risk levels. And we need to get a, let's say, we need to get an EpiPen for someone. This is just an example. I only have access to what I'm allowed to do. If it's a type certification, that would change. And I want the system to figure out the best way to fly from here to here, because if I drove this would be an hour. If I fly it, it should, we'll see how long it is. I think it's about probably 2 minutes. And I may have not got the best flight corridor. We'll see, we may have clipped the, no. So what happened is we went into a restricted area and it can't make it work. So it's running, as you could imagine how complicated this is. This usually takes about 6 months to get all of this data pulled together. And now I've just got approved. It says I just have to submit it. I'm gonna do a couple things. As a pilot, I need to build out a safety case. This is where a lot of this GIS data comes into handy. I'm gonna submit this to the FAA at the same time. So I just built out my safety case, which used to be done manually in most cases. And at the same time, sorry, that popped up. At the same time, I submitted to air traffic control. And here we go. So now me as a pilot, I didn't have to talk to the FAA. I didn't have to talk to the Miami airport. I didn't have to talk to the county or the city. I was able to build a safety case. The air traffic control tower now has my name, my phone number that's sitting on their air traffic control. They can call me right now and say, hey, shut it down. They do have a button on the screen as well at 700 airports that they can shut this down, and then it would come through our system in email or text message that pilot to say shut it down. So right now I have the air volume at 200 feet approved for the next hour. So as you can imagine how complicated that was a year ago. It minimum was probably 90 days, and I was able to do that pretty quickly. The Beyond program is going to start to, now this is a digital authorization. The next piece would be, well, what is your surveillance process for this area? What is the communication networks, all of that? And that is where our partners are using this system to then build that next level. And that data does actually sits inside this platform as well. But at least you can see what's available today. And then I am getting an advisory. Again, there's another rule that I'm within 3 nautical miles of a stadium. There's actually something happening here. I'll be interested to see what that is. I don't know if I can edit it since I I can't. I'd have to create a new operation. But what it's doing is that's what something is happening on the ground there. And it's not allowing me to fly through there. Now I could force the flight, that's what, to fly through there. But at this point, let's do it since we have a little time. I'm gonna force the flight through. That is trying to override the rules, and it's yelling at me already. It says I already have a flight going through here. So I'm gonna have to change the time. So the system's smart enough to know that there's other flights going on and not letting me get this one approved as a single operator. We'll see if this goes through. Yeah, so it's fighting it. Looks like it's fighting to get this authorized. And I'm just probably gonna let it go and move on. So let me finish out the slides. And that was the system running live. Everything you saw there was live and fully in production. And we have a lot of that deeper data that you're seeing is being done at hyper-local locations, high population areas throughout the US, and will be introduced into the system pretty quickly as well. Some of the customers that we saw, sometimes it's easier to start with cities and counties and more progressive. And for example, Ontario, California has really leaned into this and has had this platform now in place for a year. And they will actually have some of the first drone operations with a commercial company. They actually have their developer building, I think they're building 59,000 new homes south of the airport. The developer is actually helping build a drone-friendly community so that with the system helping plan it, and some of those first package deliveries are set to happen in June. They're also, so what's happening is now they're sitting across the table as a transportation and innovative city, and sitting across with companies like Matternet and some companies that are looking to set up operations for medical delivery between hospitals, and there's some pretty decent factories there and they're using the system to start help plan. And it's making it really easy for them to figure out how to fly and permit these operations, because the builder is actually building a takeoff and landing locations throughout the community. It's not house to house to begin. It's the retail center near CVS and Starbucks, single takeoff location, and then in the community they're having a few community landing locations that are secured as well. But again, you need the city involved to even understand how to permit this stuff, and this is what the tool allows them to do. They did have, like I mentioned, Esri has launched an amazing product, Site Scan, and the City of Ontario has it, and they use it for scanning for transportation. There was an incident recently that they did have to launch the drones to collect data in a tough situation. Esri recently integrated Airspace Link's data into Site Scan. In the upper right, you can see it's actually the Airspace Link logos in the Esri Site Scan product, and that allows you to have a seamless operation. So think of it this way: I need this drone to go fly this area, collect all this information, get all the authorizations, fly yourself, come back, upload the imagery, process it, and allow me to bring it to an operating center, public safety, or community meeting within hours. So it's pretty nice that Esri stitched this all together. So as a customer out there, whether you're transportation and want to do road inspections, all of these systems and authorization is built in. So you saw our system separate. It's being integrated seamlessly through APIs into drone manufacturers and software providers. The neat thing is the transportation departments can help support advanced data, not just the FAA rules and regulations, but also the supporting data of, are you about to fly over a school or a hospital or helipad, or some of the localized data that's coming from a lot of the authoritative GIS sources. And you're free to communicate with Ontario. They are doing a lot of really neat things there at just the city level. Detroit, same thing. They're doing some pretty amazing things. They are, even looking to bring in drone manufacturing because they have these test sites set up, and they're working with NASA to start to integrate multiple airports, Willow Run with DPW, and they have set up this digital infrastructure. And this is something that's really neat. Is 1 year ago when we met the first city of Taylor in Detroit, or suburb of Detroit, their first reaction is they said, how do we put in ordinances? We don't want drones. 2 weeks later, they started seeing the opportunity size and have gone the complete opposite. So now they're inviting drone companies in, and some of their operations are starting to happen, and they're supporting drone operations because that community acceptance was done through this data. And now there's a significant project where it's going to be almost all of Michigan, and there's actually a corridor that Aerotropolis is part of between Ann Arbor and Detroit, where they're focused on autonomous vehicles between Ann Arbor and Detroit. But at the same time, we're working on evaluating, well, what infrastructure is going in for that will support operations above the road or off to the right, or however the rules and regulations are set up. Currently, flying over vehicles at certain angles at certain speeds aren't allowed. So that is all being taken into consideration. But the infrastructure that's going on, being put in, can be leveraged, not just for ground transportation, but now air, because it's 400 feet and below or 500 feet below, and it's creating a great double value in some case. So that is it for what's happening in the drone industry. I covered a lot, from recreational pilots, Part 107, advanced operations, to how do you maintain a system, to all of that, and hopefully you can see how GIS and Esri plays a massive part of this, because it's all about the digital infrastructure required to build it out, use it, stay compliant where you're flying. And again, I encourage any Department of Transportation, city, state, to create an account, and what will happen, you'll be able to see what your city or county or state looks like, and progress it from there. Thanks, Terry.
Okay, thanks, Michael. That was really, really well done, and I hope that it has sort of got all of you thinking about some of these issues as we look forward. And again, I think the real critical issue that DOTs, MPOs, and the cities and counties really need to start thinking about is really how do we, based on land use data, how do we create these corridors that maximize safety, but also then really sort of maximize the ability of these providers to operate in your jurisdictions. And I think that the safety is the critical issue, and that's really where I think that Airspace Hub is really the sort of a great tool to help you really sort of understand and how do you define those corridors. So if you haven't already started thinking about those issues, the time is now. We're already well into these issues, and again, the last thing that we want is really sort of a uncoordinated future network. So I am going to open it up. Feel free to type your questions into the question box, and we're going to start. I guess there's one question early on, and you actually showed an application with Wing. Did you work directly with Wing, the question is, or and with their UAM software?
No, we did not work directly with Wing. They were up and running before we came around, but we did sign a data agreement with the communities that they were operating in to start to do some assessment.
Yeah, this person was part of the flight operations team, so yep. That was, I think, why he was interested. Let's see.
It's a great example, and one of the things, just to make sure people understand, is that Wing has their own UTM for their system, but so does Flytrex, and so does Matternet, and so on. And what's happening in Calais. So what we're doing is we're looking at peering the system, so they all connect together, they operate, but then ours is actually connecting to the governments to peer the data that's happening between different operators within a community. And I hope that makes sense. It's a bit of a federated system that Google's going for, and we're making sure that we pair nicely with that as well.
Okay, there's sort of both a question and a statement. The person says, I'm glad that scooters were used as an example as the importance of thinking ahead. And that's probably, yeah. I think a lot of cities got caught a little bit behind the curve on that one. It says, one of the challenges that remains with micromobility for local governments is having tools to aggregate MDS data for enforcement purposes. And pushing digital policy back out to scooter companies via an MDS policy API. While there are some aggregator tools out there, there are many local governments who prefer to use Esri tools, since this is a GIS problem and local governments already use Esri products. Looking ahead, once digital infrastructure has been developed for UASs, are there considerations for standardizing UAS data that could be extended to local government for policy creation and enforcement? And will the AirHub platform act as a data aggregator that can be extended to local government MPOs that will give the proper tools for policy creation and enforcement? So very long question, but yeah, I think some real great key issues in there. And I think really sort of drawing on kind of the problems that cities have had with some of the micro mobility providers. He's really saying, all right, how do we get out in front of those issues? And similarly, how do we get out in front of the issues relating to UAVs and enforcement policies? So I'll let you.
Yeah, so I'll start with the data standardization. So right now we've worked with MITRE. MITRE's been a big part of the whole North Dakota deployment on standards. We're part of ASTM, so we have a lot of staff just to keep up with all this. We didn't come up with these models directly. We worked with NASA. We took the NASA model, We built that out in using JARIS and SORA models for air. And then in some of the ground hazards, we're bringing it all together into a single system now by using all these existing companies that have already built out these standards or models. It was hard to figure out how to fill the data. How do we, aviation companies have a real hard time trying to figure out how to work with state and local governments. And that's where Airspace Link is building that integration between the two so they can understand, or they never really have to worry about ground hazards and risks of flying through communities because it's at a certain height and it's a single airport. Well, now we have airports and every landings at every other yard. So that's just a massive different scale problem, and that's where we came in. Is let's take the existing models that are out there and that have been being tested, and then make it scalable, and then make it consumable and usable in such a way that transportation departments don't have to think of something new and manage a new map service and be educated on this. Everything you saw was trying to take something that already exists and repurpose it. That's on the data side and the standardization, and yes, those are in place. And then actually North Dakota and Nick Flom is helping define those with the FAA through our system. The other thing about the scooters is the FAA is not going to allow the things that happen with scooters, and really has to do so much on safety. The safety track record of the FAA is incredible. So when you see the models that you see here, when you put in your type of drone operation, drone type, size, weight, speed, the goal is to get a 7 to the negative probability of hitting someone on the ground, and that's a standard, sometimes higher. Hopefully we're relaxing them in some cases. So those standards are being put in place. So the data, and we don't think it will happen like scooters, but if all these type certifications happen and they have our data and all this compliance system in place, the infrastructure is actually going to be the one that holds it up, because you have to get your infrastructure safety cases and data approved as well. So the state and local governments will be involved a bit more through this system, plus the hardware, that the shared infrastructure that will be required to support it. So I hope that made sense, that you will get pockets of operations that might be out of your control, but to scale it, at real scale, it will be a shared, like roads. UPS uses the road highways for your city, and so does Amazon, and so does a citizen, and so does a business driver. It's all using that shared infrastructure. So on a scooter, they just kind of blast it out, and there's no safety or security risks, at least at the present moment when they launch.
Right. So, and actually an excellent question, and I think that's one that most cities really should be thinking about, is how do they get ahead of this, and how do they participate and really help define the safety corridors. Another question, what protections are there for wildlife and habitat areas, or say flocking birds? And I do know that, I've seen videos of eagles attacking a drone.
Yeah.
So,
absolutely. So Lee County, Florida, great example. We would have never known that they said, hey, we map all the eagles' nests. Can you put those into the model? And now they're in the model. So our model is constantly evolving, way beyond what we ever thought by our deployments that we're going. So the county actually introduced that type of wildlife capability. And so are there other examples that will pop up? Probably. And there'll be a risk score tied to that. And then there'll be a risk score based on the type of drone and what it could handle. And it's true, as a driver, when I drive down the street, I grew up in Vermont, there's a chance of hitting a moose pretty massive. These drones are probably going to hit, something at some point. It's just, that is what transportation is. And it really depends on the type of drone. Some drones are only flying at 20 miles an hour. If it's zip line, they're flying at 80 miles an hour. Flying through rural areas. So they'll have to do with the ConOps and the drone type.
Yeah. So, okay. And another question, what is Airspace Link's plan to interface with the current FAA air traffic system and current airspace uses?
Yeah, so today we are responsible for the lightweight UTM through LANS. the deployment in North Dakota is we're OEM'd into Thales, which is a air traffic control for manned aircraft system. So we are integrated through APIs. So they manage the manned aircraft system. We manage the low altitude data and parts of the flight telemetry that then goes into that system. So Airspace Link doesn't do the actual manned aircraft collision avoidance systems. We sit in the low altitude. Now, since we're a geospatial platform, it is being used for collision avoidance in the mapping sense of where to adjust the flights and airspace deconfliction. But we rely on the big companies to do the true manned aircraft collision avoidance system. And North Dakota is a great example where they created almost like one single air traffic control tower in the state for the entire state for unmanned, but it still ties into the manned traffic system between all the airports.
Okay. And another question, does the system, and it's not just the system, but are flights allowed over private property?
Yes, flights currently today. Now there is a law that's being pushed pretty hard. It is Lee law. It is, they're looking for an altitude. As of right now, the FAA owns from the blade of grass up. The Lee law has been out there, and the potential of managing airspace at 200 feet and below would be state and local government, and then it takes off from there. And then in our case, we'd manage 200 feet to 400 feet, unless we're approving drop-off and landings and stuff like that. So as of today, there is no private property unless it's risk to the operation. So the state and local governments are supporting the safety cases that help drive these corridors. But if today's private citizen, there's no stopping at this point. And that's what allows the system to, these cities to understand where and why flights are happening. And in some cases, it goes the other way. Why can't I fly my drone? Well, you're in a flight pattern location with 0 flight height for drones. So the system helps you understand why and when. If a citizen complains, you have a tool to go in and look and see what's going on in the airspace.
Okay, another question. This is going to dive down. Is a real-time RTK CORS network required or helpful for drone navigation or other required or preferred data? Will real-time networks be helpful in other ways moving forward, and how? Yeah.
So if this relates to like 5G and it's absolutely, some of these safety cases that we don't do, but we make the recommendations is the communication networks. What happens if the drone loses connection? Those are part of the process. So in the evaluation of these cities, that even what you're seeing on the screen, we're also evaluating where potential lost communications are, and what is so that's marked as a hazard and a risk, and what's your mitigation plan for it. So yes, real time is absolutely important, and there's networks being placed in these locations for better communication. So when I talked about the infrastructure going in for the autonomous vehicles, the communication networks, well, how can we use that? And what's the redundancy of it? Because that's really important. Surveillance, communication, all of that is part of this process.
Right. Okay, next question. Can community acceptance and drone noise also be a consideration in the risk assessment to develop optimal flight corridors? So sort of.
So if you're seeing my screen, that's the train lines. Like in Chicago, the train lines are amazing because they're already loud. And if a drone hits a train, it's not going to cause any issues. And we're talking 55-pound drones or less. So yes, noise is a factor, and that is just another one. The air taxis and the takeoff and landing locations, NASA has built out a model, and it is built on a lot of the data that you see here. It is land use, zoning, population density, all that goes into it, to those decibel noises. And then these drones are actually being tested for decibel too. So think about this, when I put in all the variables of my drone, it starts to figure that out. But they are making them quieter and quieter. And someone mentioned the wing drone. Again, that's something that they've been making more and more quiet at every iteration that they can.
Okay, well, unfortunately, I think we've run out of time. As I look forward, I can see the future of really governments defining these corridors, these air corridors, and in fact, network analysts being used to actually do optimal routing across these corridors. So we do want to thank, first of all, Michael, thank you and Airspace Link for participating in the webinar today. We want to thank everyone on the line for attending, and we hope that you've enjoyed this and found this useful. As I mentioned, it will be available on the website in 3 or 4 days, roughly, for those who, your colleagues that maybe also would need to see this. So with that, I want to thank you all, and thank you for joining, and we'll hopefully see you in the next in a future webinar. So thanks again. Bye-bye.